Since the beginning of civilization, there is an essential component of human life: time. In our entire life, from birth to death, we always keep track of time. As humans only have a limited time in their life, we always desire for everything to be faster. Our desire for speed changes how humans value time over the decade, from days to hours, from hours to minutes, from minutes to seconds. But now, this order of time is not enough, as human was starting to harness the ability to manipulate the fastest thing we knew: light. One of light's modern application is LiDAR, which stands for Light Detection and Ranging. LiDAR utilizes the reflective property of light to obtain the position of surrounding object. To obtain this information, LiDAR emits countless of light to its surrounding. As light touches the surface of an object, that light will be bounced back to its origin, and by measuring the time needed for the light to travel from the sensor to the object and back to the sensor, LiDAR can measure the distance to the object. But because the light travels at an amazing speed, the interval between the transmission and the receiving event happens in a very short time, in the order of picosecond. Here we propose a design for a time digital converter, an IC that can tell the time difference between two events as a digital signal. The time digital converter works by receiving two electrical impulses as inputs. Then the system will convert the time difference between the two inputs to 10 bits of digital signals with a resolution of 1 picosecond. With the size less than 1 mm square, our time digital converter design could be integrated in any chip easily. Since the technology is moving to the direction of mobile devices that run on battery, our design have a low power consumption with 4 milliwatts of power rating for longer operation time. These speed, size, and power advantages are possible because of the SAR topology used as the analog digital converter. Our SAR ADC uses the new metal oxide metal capacitor in 65 nanometer CMOS technology, which is more superior in terms of size than any other type of capacitor, thus providing a suitable time-to-digital converter for LiDAR application. Our time digital converter application is not limited to just LiDAR. It is also applicable to any other application that required a time of flight calculation between two events, such as all-digital phase lock loop. In our design, the most significant bit is interpreted as a sign bit. Our time-to-digital converter could determine which input event happened first. With these advantages, we hope that our time-to-digital converter could be used to expand the electronics world and help other engineers in their effort to improve human life through their creation.